Hey everyone, we're going to be looking at how you can model the formation of an ionic bond when an ionic compound is formed. So ionic bonding occurs whenever we have a metal that transfers one or more electrons to a non-metal. Remember, metals have a weak force of attraction between their nucleus and outer electrons. Nonmetals have a much stronger force of attraction between the nucleus and the nonmetals. So, metals such as sodium tend to lose electrons, and they're going to become what are called cations, the positive charge. Nonmetals tend to gain electrons, and they're going to become anions, which are ions with a negative charge. Because you're going to get an attraction between a positive ion and a negative ion that are all attracted to each other. These ionic compounds are going to form what we call crystal structures or lattice structures, and they will be solids because all the ions want to clump together into a nice compact form, and that's going to make it a solid at room temperature. But it's made of all of these positive and negative ions that are all attracted. These are the steps for modeling the formation of ionic bonds, and we'll do a few practice on the next slides. So first, you're going to want to draw Lewis diagrams of each element. So make sure that you have your periodic table handy and you're able to identify how many valence electrons each element has. Because remember, Lewis diagrams only show valence electrons. Then in the diagram, you can add more of each atom if necessary to show that each atom is satisfied. What do we mean by satisfied? We mean having a complete valence shell, or in other words, an electron configuration that is similar to a noble gas. Then the next step is we show these brackets in the diagram that indicates that we're done with modeling what happened with the electrons. And then you add these charges to show what the ion charge would be. Finally, you write the formula using subscripts. This example, the NaCl, does not have any little numbers at the bottom. We could technically write it as Na1Cl1, and that would show the subscripts, the little numbers that show the ratio of the atoms needed. But if there's only one of each, we don't need to actually write the subscripts. The best way to learn this is just to practice. So let's say we have potassium and bromine. You're first going to look on your periodic table and find those elements. Here's potassium, here's bromine. So I have a metal and I have a nonmetal. I look on the periodic table to determine how many valence electrons each one has. Since potassium is in column 1, that tells me it's going to have 1 valence electron, so I draw 1 dot. Then bromine, since it's in the 7th representative column. On this periodic table, it says 17. We have to remember it's the 7th representative column. So 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Next, we're going to show the transfer of electrons. Potassium has an extra electron it wants to lose. If it loses it, it will have an electron configuration like argon. It's going to lose that 1 electron. Bromine, on the other hand, wants to have a stable octet of 8 electrons, but it only has 7. So we can see that potassium is going to lose that electron and bromine is going to gain it. So we use the arrow to show the transfer. Next, we indicate The potassium does not have that outer electron anymore, so I'm not drawing any dots, but I put the brackets and I indicate its charge. It lost one electron, which means it's going to have a +1 charge. Bromine, I draw next door. It now has 8 valence electrons because it gained the one from potassium. It then has a -1 charge because it gained a negative charge. Each of those atoms is now satisfied. So I don't need to add any more atoms to the picture because the charges between them cancel out. And so what we have is one of each, and I can just write my formula as KBr. I scoot those element symbols together to show the formula, and it's KBr. How do we name it? We always name the metal just like it is. So it's potassium. But then we change the ending of the nonmetal to "ide." So instead of bromine, it's going to be bromide. So the name of this compound is potassium bromide. Remember, it's going to form a crystal lattice solid because there's not going to just be one of each. There could be thousands and millions of potassiums and bromines, but the ratio between them is 1:1. Let's try another one. So this time we're going to use magnesium and chlorine. So first, find them on the periodic table. I see that magnesium is in column 2. Therefore, it has 2 valence electrons. Chlorine is over in my representative column 7. It has 7 valence electrons. So there's my Lewis structures. That's the first step. Next, I'm going to start showing the transfer of electrons. Magnesium is the metal. It's going to lose electrons. Chlorine is the nonmetal. It's going to gain. So I can draw an arrow showing 1 electron being transferred to the chlorine. But now that chlorine is full. Once it reaches 8 valence electrons, it's a full, stable valence shell. So we cannot add any more to the chlorine. But that magnesium still has a valence electron that it's going to lose. So where does it go? What we can do in this case is add another chlorine to the picture, wherever it'll fit. There's another chlorine. That other chlorine also only has 7 valence electrons initially. So there's my 7 dots. But now there's a place for that other magnesium electron to go. Magnesium needed to lose 2 electrons. Each chlorine only needed to gain 1. Therefore, we had to add 2 chlorines to the picture. So what do our ions look like? Magnesium lost 2 outer electrons, so now it doesn't have those anymore. So I'm not drawing any dots, but I put my brackets and I put the charge. It's going to have a 2+ charge. The chlorines are now going to have a full 8 in their outer shell. So I draw the bracket with the 8 dots. Oops, there's the 8 dots inside. Each of those chlorines only gained 1. So its charge is a -1. However, I'm going to show that we needed 2 of the chlorines by putting a little subscript. I'm going to put that 2 at the bottom to show I needed 2 in the diagram to make every atom satisfied. That means our formula looks like this. MgCl2. Now, when we name it, we just follow those same rules as before. Name the metal, just like it was, magnesium. change the ending of the nonmetal to "ide." So it's called magnesium chloride. All right, try these on your own. Let me know if you have questions. I hope that was helpful.